Alright, so in this video we're going over 7-4, similarity in right triangles. Now, right triangles have a unique feature. Right? That unique feature is if you draw an altitude from your right angle to your hypotenuse, that altitude divides your right triangle into 3 symmetric right triangles. What do I mean by that? Well, let's draw this altitude in. Not very straight. Name that point D. Now, we have triangle ABC. We have the big one. Then we have this little one here, ADC. And then we have this little one over here, CBD. Alright? Now, all 3 of these triangles here are in fact similar. Okay? So, we can write our similarity statement by simply matching up the sides and angles. So ABC, triangle ABC. Now, if you notice, of all these triangles, we have a short leg, a long leg, and a hypotenuse. Okay? So for triangle ABC, this is our short leg, this is our long leg, and this is our hypotenuse. Okay, so I started with A, which is the angle between the short leg and the hypotenuse. So, let's look at this other triangle here, and I'm going to change colors. This triangle ADC, we know this is the short leg, we know this is the long leg, we know this is the hypo. So, since I started this triangle with the vertex between the short leg and the hypotenuse, I need to start this next triangle with the same angle between the short leg and the hypotenuse. So short leg, hypotenuse, if you notice, it is still angle A. Okay? Now, next I went to B. B is not the right angle, because now all that's left is the non-right angle and the right angle. So, if we look at A, our next angle would be C, because it's not the right angle of this triangle. And now we'd finish it out with D, which is the right angle of that triangle. Okay? And that's similar to triangle. Now let's look at this one here. If you notice now, this became our short leg. And it's okay if one leg, because this will happen, this altitude here is the long leg in one triangle, but the short leg in the other. That's fine. That's how it happens. So that's our short leg, this is our long leg, and this is our hypo. Okay? So now again, we need to start with the vertex between the short leg and the hypotenuse. Short leg hypo, angle C. Then go to the non-right angle, which is B. Finally end up at the right angle, which is D. Okay? So now, this is the similarity statement for these 3 triangles. And all 3 of those triangles are proportional. They're similar. Okay? Now, we can set up ratios with this as long as our ratios, well, it'll be easier to show you. Basically, if I wanted to find a similarity ratio between these 2 smaller triangles here, what I could do is do the short leg of this triangle, which is AD, over the short leg of this triangle, which is DC. That would equal the long leg of this triangle, which is DC, over the long leg of this triangle, which is DB. Okay? And I could also go one more. Well, I'm not right now. Okay? So we have short leg over short leg equals long leg over long leg. Okay? So, say we had this side, but we're missing, say we had AD and CD, but we're missing DB. We could use this formula right here to find the length of DB. Therefore, and then from there we could find the rest of the information in the triangle. Okay? So it's just proportions. That's all it is, just proportions. And as long as you keep things in the same place, because this is short leg over short leg, okay? This is short over short equals long over long. So as long as you keep things in the same order, you're fine. Okay? Because if you notice, I could have done this short over long equals short over long. Basically, these two would have flipped, and it'd be the same thing. All right, so as long as you keep it in order, short over short, long over long, or short over long and short over long, your proportion will be set up correctly, and you'll be able to then cross multiply and solve for your variable, or reduce it down and see what your scale factor is, or your similarity ratio. Okay? All right. So let's do a quick problem. Say we have this triangle. Hopefully you can see that. All right, we draw our altitude here. We know from here to here is 2. And we know this is 4. And we want to find x. Okay, we want to find x. Well, let's look at this. Of this triangle, this is the short leg. This is the long leg. Of this triangle, this is the short leg. And this is the long leg. So let's do short over short equals long over long. So short 2 over short 4 equals long. Now, since I did the short of the smaller triangle, I need to do the long of the smaller triangle. So this is a smaller one, so 4 over x. All right, 4 over x. So now we can cross multiply. 2x equals 4 times 4, which is 16. Divide both sides by 2, x equals 8. So there we go. We just found the long side of this triangle. Okay? And as you can see, 2 to 4, that reduces down to 1/2. 4 to 8 also reduces down to 1/2. Our scale factor is the same. All right? We can also use that to find some information of a big triangle if we needed to as well. All right? Proportions, that's all this stuff is, guys. Proportions is what we've been going over. The important thing is to keep things in the same place. I can't stress that enough. Keep things in the same place. This is the short leg of the small triangle, so this has to be the long leg of the small triangle. This is the short leg of the large triangle. This has to be the short leg of the larger triangle. Now, I'm not talking about the original triangle. I'm just talking about these two here. This is the bigger one. This is the smaller one. Okay? Now, let's go over one more concept real quick. It is called, I'm going to write in red. It is called geometric mean. All right? Basically, if you ever have a proportion that looks like this, a over x equals x over b. Well, if you look at that previous problem, okay, we have 2 over 4 equals 4 over 8. Look at there, okay? These two are the same, all right? So, for finding your geometric mean, you would cross multiply. X squared equals a times b. Take the square root of both sides. X equals the square root of a times b. Well, if we bring that problem we just did in, we have 2 over 4 equals 4 over 8. Okay? We can replace these 4's with x's. Okay? So those 4's are now x's. Now let's draw a formula, and we're going to find that 4. Okay, so x equals square root of 2 times 8. What's 2 times 8? Well, that's 16. Well, what's the square root of 16? 4. All right? So that is how you find your geometric mean. Now, if you notice here, let's go back to this original example. If you notice here, the length of this altitude is the geometric mean of these two segments of the hypotenuse. It'll always work that way. This altitude here, this 4, this altitude will always be the geometric mean of these two sections here that it divides the hypotenuse of the original triangle into. All right? So if we were just given this information, like this, like we don't even need short and long anymore. If we were just given this information, 8, here, all we'd have to do was go, oh, well, this x here is now the geometric mean, So we know that x equals the square root of a times b, this being a and this being b. So x equals the square root of 2 times 8, which is the square root of 16. So x equals 4. So therefore, that is 4. Okay? So, not only can you set up a proportion to find this stuff, this altitude will always be the geometric mean of these two segments of the original triangle's hypotenuse. Okay? So, that's pretty much it for this lesson. Okay? I could just pound problems into your head, but we can do that tomorrow in class. Okay? Because we're going to have our worksheet on this. So, make sure you understand what geometric mean is. Make sure you understand that when you have a right triangle and you draw an altitude down, all three triangles that are there are now symmetric to each other. All right? And you can set up proportions to find missing legs or hypotenuses, as long as you keep in mind of short over short equals long over long. And if you put the small triangle on top, you have to keep the smaller triangle on top. All right? But all of this is all proportional. Okay? So, that's 7-4. We'll work on the worksheet tomorrow. You can watch this video as many times as you need to. Take some notes. See you tomorrow.